Welcome to week 2 in Java. I've been busy grading all of your work. It's been great. I hope it's all making sense. If not, reach out to me, please. I hope you're really enjoying the sandbox environment, that you can keep trying and getting it until you're happy with it. Hopefully this week will be a little bit easier because now you have JGrasp installed. You have your environment kind of figured out. You've got your online book, but let's head into our second module. And this week, we're really going to be talking about variables and holding values. So I thought we'd start out with a little bit of code in JGrasp. So we're going to have several types of variables. And what a variable is, it is a data type that remembers inside of this particular class, inside of this particular method, what a value is so that I can use it. So in this particular piece of code, I have 4 different variables. And just like when you took algebra, X stood for a value. Well, in this case, these variables stand for a value. Well, the first one I have is called a boolean data type. And boolean is one of the easiest ones because it's either true or it's set to false. So for example, if someone made a statement that said COVID is gone away, well, that could be true or it could be false. So the answer to that statement is a boolean data type. So I've taken this data type called boolean, and notice when I type it in, it's a lowercase b. It's in purple because it's a command, a reserved word. And this is my variable right now. It is called, is it a nice day? And if you look at my caps, this is called camel case because the beginning of each word except for the first one is capitalized. So it, a nice day. So this is my variable. And it has to be either set to true or false. After I declare that variable, I end it in a semicolon. Hey, my second one is called a character, or we just say char. This stands for a letter or an individual, anything that you could type on the keyboard. So an individual key on the keyboard. So my character has been set. My grade in this class, that's the variable, hopefully is going to be assigned to an A. And notice, if I'm going to do a single character, I'm going to put a single quote around it. So anytime you use a character, whatever you assign it to is always a single character. So that's the letter A in this case. It could actually be a symbol like a plus sign. It could even be a question mark. It could be a number, but usually we don't use a number because a number is going to do some kind of mathematics. But if the number wasn't, for example, a character could be, maybe I live at 8 Rivermont Avenue. The 8 would be a character if I wasn't using it in any math way. Hey, next, guys, I've got an integer. And it's set to my age. Well, this isn't true, so it's not a Boolean. Let's say you guys are 25. So integers are values that are positives and negatives, but no decimals, like -1, -2, 1, 2, 3. So if it's a rounded off number like 25, and we'll talk in a minute, there's a range for what makes an integer. And if I have a decimal, the most common one is called a double. So this is another data type. I'm going to call it my pay rate. And let's say you get a programming job and you're making $36.75 an hour, which is definitely very typical in our field. You're certainly not going to make minimum wage. And then I'm going to do 3 printout statements. These are called system.out.println. And if you remember, I'm going to put a literal it is. And notice I'm going to put a space here so that we literally get the space to show up. Because it's this is it a nice day is this Boolean that was set to the word true. So it's going to actually say it is space true, quote, space, that it is a nice day. And the reason that I'm real picky about putting the space there and there is if I don't put a space, it's going to run the word true right into the statement. So it's going to print out, let's look down here. It is true that it is a nice day. Do you see this word true is from that boolean statement. It can only be true or false. So if it's not a nice day today, for example, maybe tomorrow's going to rain a lot, I could change that to false and it would print out it is false that it is a nice day. Hey, let's look what our second line is going to print out. Print line. I expect to get, notice the space, my grade in this class. Well, this my grade in this class is set to an A. So it's going to print out A in this class. The reason I have a space here and here is to make sure it doesn't run together. Let's look down here. I expect to get an A in this class. Notice a couple things. When we connect a variable to a literal statement that's in green, we have to put a plus statement. This is called, it concatenates the two together. We'll talk about more of that word in a second. And then let's look at this. Age is my age. I want there to be a space before and after it so it doesn't just run it all together. So age is 25 and the pay rate, whoops, let me run that again. I'm going to hit build and run again, and we'll see that it's now $36.75. So my age is 25 and programming pay rate is, my pay rate was set to $36.75. And variables can be changed. Let's say you get a raise of $1. If I now run it again and hit run, I would now get these variables to say, you're now making a pay rate of $37.35. Pretty good. So now that you've seen the code, let me give you the backstory here. So we can declare these constants and these variables. Now there is a difference. Constant means it can't change. We haven't seen one of those yet, just so you know. But constant is like saying in a program that pi is equal to 3.14 and onward and onward. That's pretty much a constant. We'd have to put some form of code. You'll see it in a moment. And that could be a literal constant. It's a value taken literally at each use, or a numeric, in other words, numbers. And you can also have an unnamed constant. And this is when you wouldn't have an identifier or a variable like that camel case item that you saw earlier. What we just looked at earlier, it was called a variable. Think of it when the computer sees the integer int and you put a camel case identifier, which in this case is a variable, and put equal sign and let's say a number. What happens is in the computer's memory when this program runs, it stores that in its memory. And a lot of you have heard of memory like RAM, random access memory, where it stores what it needs to run the rest of that code. And we're taking it for granted that if I assign that variable, I'm going to be using it later and grabbing it out of memory. And especially if you're going to grab something out of memory over and over again, you don't want to keep putting it as a literal. It can only hold one value at a time, and its value can change. That's why we call it a variable and not a constant. And each of these variables are assigned a data type. And this is telling the computer, okay, this one's going to be a number. And what type of number is it? It's an integer. And it also determines how much memory it occupies. So if we assign it to a double, and it could be a very, very large number with decimal places and everything like that, it has more allocation of memory versus something called a byte, which is very, very, very small piece of data. So, and it also determines what kind of operations can you do with it. For example, you cannot add two booleans together. You can't say true plus true equals false or something. So it determines what can you do with that. And we're going to see something called a primitive type. It's a very simple data type. It's usually very small. And then we have these references type, which are a lot more complex, and I'll refer to them when we get there. So here's your first little list. These are some of the most common Java primitive data types. So these are like a byte, very, very small number that only is 1 byte of memory, the smallest unit. You could have a short integer. By the way, these are very small. We're going to get to how big are they in a moment. You have an integer. All 3 of these cannot handle a decimal, nor could this first one. A long integer is just a super big number that doesn't have decimals. Maybe, for example, how many feet is it from here to the sun? That would be a long integer if I didn't include a decimal. And then these 2 are types of decimals. We call it single precision or double precision. Just think of that as not many digits, and this one a lot of digits. We'll get to how many in a moment. You can have a keystroke, which is your characters, or char, which is a single character usually off your keyboard, although it doesn't have to be in keyboard. There are a lot of characters that could be made that are in what we call an ASCII chart. All kinds of weird symbols, like one that you wouldn't see necessarily all the time is some kind of like infinity statement. We have boolean, and don't forget boolean values are only true and false. That's pretty much it. So let me go over some variable rules. And when you name these variables as identifiers, you have to have some rules involved. So don't forget, a variable declaration, usually at the top of your program, is a statement that reserves a named memory location. And it always has a data type, the actual identifier, camel case usually an equal sign and a value, and ending in a semicolon. So let's just look back there. Let's go through again. Yep, there's your data type. There's your identifier. There's your assignment statement, usually equals. There's your value, and then there's that semicolon. And these are typically, all 4 of these right here are what make up a variable declaration area of your code. So this assignment operator is usually the equal sign. The value to the right is assigned to the variable in the left. So when the computer looks at this line right here, it actually starts with true and goes, okay, I'm going to take this value, I'm going to assign it in memory, I'm going to create a Boolean data type with called, is it a nice day? So truly, your computer actually reads from right to left when it does this. We call it initialization when we make this declaration of a variable. We assign the variable and we declare the name of it and what it's being assigned to it. And we have something called associativity. This is the order in which operands are used with operators. We'll get to that in a bit. So kind of like the order of operations from 6th grade that you learned. So when you declare multiple variables of the same data type, you can separate these statements on different lines. For example, we could put, whoops, let me go back there again. So we can put int my age equals 25, int your age equals 19. So we could usually put these on different lines, even though they're both assigned to an integer, because they both have different variables. Now, if you use instead a constant should not change ever. So you're not going to add 1 to it and make a change. It also has a data type, a name, and a value, but it has a data type preceded by the word final. So anytime we put final in the front, you know it's going to be a constant that we're not going to change its value whatsoever. It's done. It's final. And it can only be assigned a value once. Conventionally, we always give this identifier, just so it stands out in your code, uppercase letters. Let me show you what this looks like here in a separate item here in a moment. We have the reasons for doing this. By making it all capital letters, it's easier to someone look at your code later and go, oh, that must be a constant, because they used all capital letters. And that way, it really kind of stands out so that you don't make any errors and try to add it later. So it stands out from the rest of your variables. Now I've gone back to the code and I've decided that at the end of the semester, your hopefully final grade in this class will be an A. And it's a value that's not going to change. So I've typed final in front of this. But what I would do in return is change this to my grade in this class. Why? We want everyone to know anytime a variable's all in all caps, then we know that it shouldn't be changed. So I can't assign it on another line later in this code and say, oh, no, 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 you got a B. So we would change these two items. And then so when I go to run, it's still going to tell me, yeah, I got an A, but it won't allow me to make any changes to this. So if another programmer comes in later and tries to change this grade, it would go, no, 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 it can't be changed. So it would give them an error because you can't change this. So how big of a number can these data types hold? Well, look at this chart real quick. A byte is really just a very, very small number, negative 128 to positive 127, no decimals. It only takes like 1 unit of memory, which we call a byte. So super small. But I have to tell you, I don't use byte very often, even if I'm doing something like how old are you? Your age. Why didn't I assign that to byte? I assigned it instead, if you remember, to an int. Well, I know really no one lives over 127 years old. I kind of get that, but who knows? Maybe in some parallel universe they can, or maybe we get better health care, who knows? So I don't want a coder to have to ever go back into every code in America and beyond and change the word byte to int because people are living longer. And really, used to be years ago, the rule was in coding, always use the smallest data type possible because we don't want to exceed the usage of memory or take up too much space. But now that memory is crazy cheap, it's really not that big of a difference between 1 byte and 4 bytes. I mean, when we're talking, and we use these numbers, you've heard people say it's 1 gigabyte is, the hard drive storage. So we're not too worried about 4 itty bitty little bytes when we're talking millions of bytes. So my rule of advice is typically, unless there's some reason like mobile devices, use the most common ones like int to represent most numbers, as long as it's not bigger than positive 2,147,483,647. By the way, I don't expect you to memorize that number, but if I were to have matching, let's say on a test, which is which, make sure you'd able to know, which one of these is bigger or smaller. So byte, short, long. If you really, really need a big, big number, you would head to longs. And boolean, super simple. It can only hold 2 values, either true or false. There's also something called relational operators, and you probably remember these from math class. Look over here. Less than, greater than. This means, is it equal to? I know that's different than the assignment equal to. In other words, if you had this statement, this is saying, is 7, is it equal to 7? Well, that's true. But is 9 equal to 3? Well, no, that's false. Why do we have this? If you use a single equal sign, you're actually assigning, let's say, 25 to my age. But if you're comparing two numbers, this is where you use the double equal sign. People mess up with this quite a bit, so stay tuned. Remember, if you're comparing 2 equal signs, if you're assigning a single equal sign. This one right here, less than or equal to, I know we drew this a little bit different in math class. We put the less than symbol with a line underneath of it. We can't type that into a keyboard, so we'll use this one, less than or equal to, greater than or equal to, and this on a computer is how you say not, exclamation, not equal to. So in this case, it's true that 5 is not equal to 6, but it is false that 3 is not equal to 3. I hope you thought that through. So we can have these. Now, if you have floating point numbers, we use float and double quite a bit, and here's how much they can store. These are huge. Think about this. If you go out 38 different decimal places, that's what this means. It would only still take 4 bytes to store it, but these would include any decimal from positive 3 gazillion with 38 decimal places. But if we were talking some massive scientific experiment, it would be best to use double because who knows, we might have to be really precise. And we call this often single precision and double precision. We have char, which assigns just a single character like the letter M. Make sure again that it's always placed within single quotation marks. And one we haven't talked about yet is called a string. String has its own separate class. We've created our little classes so far, but I want you to imagine there's an entire library out there in Java that deals with strings. And what a string is where you have multiple characters in a phrase, a sentence. For example, CVCC's old address was 3506 Wards Road. Although we're on a different address now. I've got to look it up. It's different now. So if we ever have a string, we're going to put it in double quotation marks. A couple unique items that I definitely want to point out, I'm about to show you in code. Remember we said not every character is on the keyboard. We call them non-printing characters. Look at this one. Do you see this \n? This actually is an old-fashioned hit enter at the end of line and go to the next new line. So you may be assigning a new line. This is an identifier, if you remember, to \n. That would just mean if you put this on the end of a character, it would skip and make whatever's printing out go to a new line. We'll see it in a moment. So you can use the new escape sequence or just use print line multiple times. Remember in our code, we did print line 3 lines, and down here we got 3 lines of output. Well, we could have put all of this on the same line by putting between these statements all on one line a \n. This \n would have to have single quotes around it. And what that would do is put all of it on 3 lines if we did this multiple times. And there are a lot of these character data types that are non-printing. They're also called escape sequences because it's like, keep printing. Oh, I've got to do whatever you want me to do. Oh, you want me to go to a new line? Let me go to a new line. And some of the other ones are like backspace, a tab, which is like 5 spaces. Of course, we just talked about new line. This is called a carriage return. Boy, talk about an old typing term. But it does move the cursor to the beginning of the current line that you're on. So it's like going to the front of the line. If you wanted to print out a double quotation mark, it's hard to print it out because usually those quotation marks are used. Let's go look. Usually these quotation marks are used here just for coding, to tell it that's the end of the line. But if I wanted to make it print a quote like that, I'll put a little space there so it's not too confusing. I could put that inside of this. So I could put +. And what this would actually do here is we could, boy, that's a long statement there. This would actually tell it to print after day to print a little quote right there. So now if I were to run this, this would put that little single quote. Let me show you how I did that again. I put a + and put a single character code of \double quote. Let's look at that. And if you look back at that, what that would do is just print a single quotation mark or a double quotation mark. It's up to how I choose to do it. If you need to print a \, you could put 2 backslashes as a character, and it will print that \ in your printout. So now let's kind of put several concepts together by looking at this code. Let me start off with line 1. Do you see this import space java.utility scanner? What this is doing is saying, we're going to be using a special library called scanner in this piece of code, and you probably can see scanner coming up here. What scanner is needed for this special library that we need to import? What import means is I want to take this library section, pull it out to use inside this code. so that we'll know what to do in this. So why is this program so different that needs this scanner utility? What this code is going to do is, for the very first time, allow the user to type something in when the program is run and then use that in the rest of the code. So in this particular program, let's look, we've got the public class. I'm going to call it input demo as my class name. So this is my little how to input demo. Notice my opening brace, my closing curly brace. This is my method, always need main. Here's my opening brace, my closing brace. In line 6, for the first time, I'm going to assign a string. And if you remember, we said string is going to be a special class that is going to store a large phrase or sentence, or in this case, someone's name. And it could be their first, last, middle name, everything. We're going to be asking for their name. We're also going to have an integer that's going to represent their age. And yes, I could have used byte here, but I never know if someone's going to put a crazy age, like they're 900 years old, like Methuselah or someone. So therefore, I'm going to make it an integer. That way it'll accept a lot of larger numbers as long as they don't put a decimal. I'm going to also ask them what their job is. And my job title, for example, is a professor. That's going to be a string or a phrase or a word. So I'm going to call that job. And notice you're saying, why don't you have a camel case here? If I just use a short variable name identifier, I don't need to have the camel case used. And everybody look at line 9. This is the first time we're using this. This phrase is always going to be in your program. Every time you're going to allow the user to type on the keyboard and get their input typed in to this code. We're going to be asking when it runs. So this is line 1 and line 9, if you think of it, go kind of together. If I am going to use this row 9 in my program and ask for input, I'm going to need to import this special class to pull in this scanner utility. Now let's see what this program does. It's going to first print out. Now notice I didn't say print line. I just said print. The difference is if you say print line, it prints what it does and goes down to the next line to print what's next. But what I want this to do on the same line is to say enter your name and a couple arrows little here, just in quotes, but it's going to leave the cursor at the end of this same line and not go down to the next line to allow them to type right here when it's run. So if you use print, it just, whatever comes right after it is going to print right after that line and not go to the next line. So how do we allow someone to input a name? So you put keyboard.nextLine. What this line does, line 11, is whatever is typed from the keyboard, that entire line, is going to be assigned to the string called name. And we had to declare it up here first before the user inputs a value for it, so it has a location to store the user's name, like Corinne, my name, in memory. Hey, next in line 12, we're going to ask them, well, okay, we're going to reuse their name. So it's going to print out, in this case, Corinne, comma. Notice there's no space right here. I just wanted to go Corinne, comma. Enter your age. So it's because I use print, it's going to stop on that same second line because I said next line here. And now allow them to type in their age, whatever they input from the keyboard. We're going to call it next int. This is going to allow them to finish up that integer and assign it to age. And then we're going to put right here, keyboard next line. This takes us off the line we were on and moves it to the next line. And then it says enter the job description, that your title, and whatever they type in here is going to be assigned to job. And then these last two lines are going to do a little output. It's going to say name, colon, space, put whatever's in memory, in my case, Corinne, age, colon, whatever I typed in for age. And then because I put print line on the next line, it's going to print my job description is. So let me copy this code right here so you can get the feel for it into JGrasp here. And if you ever do put in some code in, make sure you resave it again. I've got to have it called input demo Java or it's not going to run. So now let's see what happens when I go to build and run. It says, hey, enter your name. I'm going to type in Corinne. Notice down at the bottom, it puts whatever I type in red. Because it said print, it allowed me to put that on the same line. But because of this next line, it's now going to hit enter and now print Corinne, enter your age. I'm going to lie right now and put 25. And so now when I hit enter, because it grabbed whatever integer was next, assigned it to age, this keyboard at next line skipped to the next line. It now says enter job description. Whatever I type on this line is going to be assigned to job. I'm going to type in that I'm a professor. And now when I hit enter here, it did this little printout of saying name is Corinne, age is 25, lie. Hey, job description is professor. So now you're starting to see we're putting a lot of new things together. I also want to introduce you to a dialog box. You have certainly gotten an error pop-up message in a dialog box before. It's called in Java JOptionPane.show message dialog. So if I want a pop-up window, instead of using the output at the bottom of the screen, let me go ahead and show it to you in JGrasp. So first of all, if you're going to use any message dialog box at the top of a program, it needs to have this library imported. It's called javax.swing.jOptionPane. It's got to be just like that. And typically if you had your opening comments at the beginning of the program, this would be down a little further. This might be where your author is, you know, all the opening comments at the beginning. I'm going to call this class numbers dialog, and of course my my little curly braces are all aligned nicely. Okay, in this program, I'm going to assign a data type called an integer. I'm going to assign the number 30 and assign it to a variable in memory called credit days. It's not a constant. If it were a constant, it would have said final in front. Now, what I want to do here is I want this message not to appear down here at the bottom. I want it to show up in this message dialog box. So here's the command, JOptionPane.show message dialog. And we put the word null because we're not going to put any particular symbol. You'll see later. And when you put two quotation marks like that, it's just called an empty quote. And if you look back at the slides we were just looking at momentarily ago, we call this a null string or an empty string. So I'm putting in JGrasp right here an empty string plus credit days. You'll see in a second when I run it. And a second show message dialog, but this one's going to say every bill is due in space 30 days. Let me go ahead and run it after I've saved it. I'm going to go ahead and hit run. And this is what a message dialog box looks like. So it just has, that's kind of an information we call null with the 30 days right here. When I click OK, I get a second message dialog box that said every bill is due in, this is where it's putting 30 days. So just another way, instead of using the output box, to do dialog boxes as well. Now, remember in the program that we did just moments before the one that had the dialog boxes, we were getting input from the user, and it had to have that system.in object, and it also had to access that scanner class. Scanner tells it to scan for input or the user to type something in. And when we use that scanner object, it's really breaking what they type in into small little units called tokens. So whatever they type in are the tokens that the user has put in. And there are a lot of scanner class methods. If you're wanting to grab input and make it a double, we call it next double. If we want to grab input and make it an integer or, pull in the entire line of text. So we have short, byte, float, long, whatever they're putting in there. So let's look at a program that has a lot of this going on right here. This is where what we looked at earlier, it has that scanner, this class is imported so that we're able to use this scanner object. This is the one that we ran earlier. And this allowed the scanner to grab the entire line of input and put it with a name. Don't forget, the reason we had to use next line is we don't know how much they're going to type in with a string. I may have typed in Corinne Lisa Hoisington, my full name. Not just a number. And when you put an age, we say next int, and then we finally printed it out on the screen. There is a problem when using one numeric scanner class retrieval method or a next method before using the next line method. What this really means is a lot of times we'll add an extra next line method to get any extra keystrokes that someone types in between. So in other words, if I've just taken in a string, I then type in a number, I don't really know when they're done that number. So a lot of times we'll put an extra new line method just to kind of get any extra characters out of the computer's memory that maybe was a errant keystroke to put in. And may I recommend, as you go through these projects while you're watching this, type in some of the same code that I am so that you can, try and play with it so that it'll make sense. I don't think if you just watch me do it, it won't make too much sense. Now, I kind of want to put all this together now. Now, we have a way of doing output and input using the standard dialog box, standard input area and output area at the bottom. But we also have a way with J option to do these little message boxes. Well, there's also an input J option message box. And here's what it looks like. Show input dialog. And this allows you to capture what they type in a dialog box and, of course, show it back out with a message box. Let me show you what it looks like. So I have got this same exact import, J option pane, for both of these, whether it be input or output. Let me just go to the output first. This is the one you've seen before. It's J option pane, show message dialog. It's going to say hello and put the person's name. What I've done in this program is I'm going to ask them for their name. I'm going to call their name a string and call it the result. And right here, I'm going to assign whatever they type in on the right to result. And how do I grab that input? I'm going to set it equal to J option pane dot show input dialog. Let's kind of compare. This one shows input dialog, and this one says show message dialog. So if we're expecting them to put input in to stop and allow them to type, that's input. If you're displaying something, it's called message dialog. So once again, null, it's going to say, what is your name, friend? It's going to assign all of that to result. And then we'll have a second message box, dialog box, that says hello and whatever they typed in. Let me show it running or it won't make too much sense to you. So now when I go to run, it says, what is your name, friend? And let's see, my best friend is a guy named David. And so I'll click OK, and it'll say, hello, David. So this is how you can use these dialog boxes instead of this at the bottom. Let's face it, these look a little more visual. So we would like to use those as much as possible. Now, what we just did is allow the user to type in a string, and we assign that to result. But how about if we're asking them to type in some kind of other primitive data type? Let's say some type of number. So when they're typing in a number, we have to process it and make it a number. Think of the computer. Anytime you ask them to input something, they pretty much see everything as just some kind of string. But if we want to assign it to a primitive data type so that we can do math with it, we have to do something called a type wrapper class. I'm going to show it to you in a moment, but I wanted to explain it here first. This allows whatever they type in to be parsed into an integer. Parse means to process it into this data type and assign it in memory so that we can use it as the right data type. It knows it can't add strings, but it knows it can add numbers. Now, same program, except I've done a little math. After I converted whatever number they typed into an integer, look at this line right here. I'm just telling it to take whatever the integer is and to multiply it by 2. In other words, doubling it. So now I've just changed the output to say your number doubled is. Now, as I go to run it, it says enter your number. I type in 33 again. But notice it says your number doubled is 66. Here is why this is so important. If I would have left this as a string, then it would have never allowed me to do the mathematics to a string. A string cannot be multiplied or added or subtracted or divided. And important to know, the computer does know the order of operations. I'll talk about that in a moment. So this is important to convert it over part ins or parse double if you're converting what they type in from a string to a usable value in your statement. And let's talk math in Java. And I'm talking basic math. This is how to add, subtract, multiply, and divide. And this one is called how to get the modulus, or what we call the remainder. Let me explain. So let's say you want to add, obviously 45 plus 2 would be 47. We could use the plus sign. Of course, subtraction, multiplication. But let me show you the difference with division. It's a little surprising. So let's say you have a double. A double means a decimal. And you divide it by 2. It'll give you the exact 22.5. If you divide 45 and a half, that's what you get. But if you have an integer and you do division, it's called integer division. It'll just find out how many times evenly did it go without getting a remainder. So if you put 45 integer division 2, the result is 22, not 22 and a half, because it's saying, well, I can't have a decimal, so how many times did it go evenly or with an integer? So why is that important? Well, if you do want to divide 45 by 2, if you then put this percentage sign, we call this modulus. If you do 45 modulus 2, this means what the remainder is. So even though 45 integer division 2 is 22, the remainder is 1. So if you put 45 modulus 2, you would get the result of 1. And please understand the operator precedence. Remember the order of operations, please excuse my dear Aunt Sally? Well, that's true here. I am going to quickly open just a blank screen so I can type on it. If I go into, OneNote here real quick, let me just add a blank page. If I do something on the screen, let me get up so I can draw on my screen here real quick. If I just do a simple math problem that I do 3 plus 5 times 2. Do the math in your head real quick. Hopefully you know. The order of operations says we always multiply before we add. So 5 times 2 is 10 plus 3 is 13. The reason I'm pointing this out is the computer knows the order of operations. If you don't know what I mean by please excuse my dear Aunt Sally, P means parentheses are first, exponents are second, multiplication and division goes left to right if they're both, and then addition and subtraction left to right last. or please excuse my dear Aunt Sally, if you're wondering and your teacher didn't use that. So now that we kind of understand that precedence, how does all this remainder stuff work? So it's when we're down to addition, multiplication, division, addition, and subtraction, the order actually goes multiply first, divide second, remainder modulus third, and then addition, subtraction. So I do want to put that in there. So please excuse my dear modulus addition, subtraction, Aunt Sally. So if you see a statement like this, make sure that, do you understand why state rate is all in caps? It must have been a constant, like a tax rate or a state rate. And it's talking about avoid unnecessary repetition of arithmetic statements. So what this means is, if you want to find gross pay, you multiply how many hours by how much you do rate, and then take that gross pay and multiply it by whatever the state tax is. And to get federal withholding, you would multiply your gross pay by whatever the federal, rate is for withholding. This is a better way to do things than try to do all of it in one statement. Break it down step by step when you do your calculations, because sometimes the order of operations might work against you. So it's a little bit easier to do a simple equation on each statement, and that way you're not going to get confused. Well, we're almost done. So a couple last things. There's this term called a unifying type, and it's important. It means that in a programming statement, if I am multiplying, let's say the integer 3, it's an integer, and I'm multiplying it by a double of 2.5, which is a double, it's a decimal, what would the result look like? Is it going to turn into an integer, or is it going to turn into a double? So here's the rule. If you multiply a double by an integer, what it always looks for the unifying type between two variables. If you have a double anywhere in it, the answer is going to be a double. It follows that unifying type. If you have a float in there, it's going, and a float in an integer, it's going to become a float. But if you have a double and a float, it's going to become a double because the order is higher. Basically, if you multiply an int by anything that's not an int, it'll probably become whatever you multiply it by because it's lowest on the totem list. A couple things, I like this, it's called don't do it. Don't mispronounce integer. I've heard people say integer, with too many R's in there. Integer, not integer. Don't attempt to assign a literal constant floating point number. So you don't want to you don't want to make that a string or something else that it's not. Don't forget to follow precedent rules. That means the order of operations. Don't forget that when you divide two integers, your result is an integer. And don't forget, if you want the remainder, you have to use that modulus, which is a percent. So lots of last things here. So go back and do the reading on variables, primitive data types, your standard arithmetic operators, your booleans, your relational operators. Boy, there's so much content in this. So definitely slow down and read through it all. Your floating decimal kinds, floating and double. Your char is for a single letter or character or non-printing character data type, but you put it in a single quote. The scanner class is to allow the user to input from the keyboard. The J option pane can confirm a dialog box or an input dialog box. Well, that's it, guys. Time to get into that homework. Replay this over a few times, read it. It's really important not to continue on to the next module because now I'm kind of expecting you to how to use a variable, how to do input, how to do some simple mathematics from this point on. Guys, have a great week. Again, always let me know if I can assist. Take care, guys.